want to sort it in my way, because going across you will see that this my way is being used a lot. For an example, we have declared a pair array, and these are the pairs 1 2 2 1 4 1. Okay, and I want you to sort according to second element. Like, I want you to sort it in order of increasing second element. Please understand, I want you to sort it according to increasing second element. Okay, and if the second element is same, then sort according to the first element, but in decreasing. What do I mean by that? So as of now, can I say the second element is 2 1 and 1? So this 2 comma 1 and 4 comma 1 are the guys who should appear right at the first. Okay, because the second elements are 1 and 1, and after that I can say after that 1 comma 2 will appear because of this portion. So can I say that I've sorted according to the second element? But I still have a problem. Now these couple of guys are having same second element. Now if they have the same second element, I want you to sort it according to the first element, but in descending, which means I want you to have 4 comma 1 at first and then 2 comma 1. That means among them, I want you to sort it according to descending. So first 4, then 2. And then you can write, so first sort it according to the second. And if there is a group which is having the same second, then among them, sort it according to the first. So this is my way. Like it's something like a combination of increasing as well as decreasing. So this is where generically you write the first iterator, the last iterator, and a comp and a comp. Remember this, and a comp. Now this is nothing but a self-written comparator, and this comparator is nothing but a Boolean function. So I've written this, but I'll just teach you how to write it. It's very simple. You write Boolean comparator, and this is the function. Okay, this has to return a true and a false. Now go back and see what is the data type that you just had. And the data type, if you see, was pair of intent. Just copy paste and have couple of guys, pair 1 and pair 2. That's it. Have couple of guys. This is the first thing that you'll do. Have couple of guys. Now please understand this, that this is pair 1 and this is pair 2. So forget about the array. And now think of just two instances where you have two pairs. This is P1, this is P2. While writing comparator, just focus. What have you been said? Sort it according to the second element. So you say, okay, if my P1 dot second is already smaller than second, 0 and 1 1 1. So build. Hey everyone, welcome back to the channel. I hope you guys are doing extremely well. So this is yet another lecture from the Strivers A to Z DSA course, and this is India's most in-depth DS algo course. Why do I say that? Because you can check out all the free courses, all the paid batches. You will not find any courses, any batches with 455 modules or 455 problems solved in it. This is the reason I'm saying that this is India's, probably world most in-depth DS algo course. Now in the previous lectures, we have covered till step 1.5. In this lecture, we will be covering basic hashing. Once I cover this, we will be covering everything related to basics that we require in order to start with DS algo. So without waiting, let's get started with the hashing lecture. So we're solving a lot of interview problems, isn't it? But whenever you go for interviews, the first round will always be coding round. So in order to clear that coding round, you have to actually give a lot of similar coding rounds in your preparation. Algo. If you do not understand hashing, you will not be able to solve announced the first prize is 1 lakh rupees, the second is 50,000, and so on. And there are a lot of prizes for other people as well. Till the top 100 you can get a lot of goodies, and going forward you will also be getting a lot of gift vouchers. So the prizes are worth 10 lakh rupees. So what I will recommend you is the link in the description. Make sure you go and register and participate in such contests, because this will help you in your preparation journey. So without waiting, let's get back to the video. Now, when I talk about hashing, it is one of the most important topics in DS Algo. If you do not understand hashing, you will not be able to solve a lot of problems in data structures and algorithms. So please do not miss this lecture, because I'm going to teach you hashing and I'll be using pseudocode. So language will not matter. Everything that I'll be teaching will be in terms of pseudocode, because for loops are similar in C++, similar in Java and Python. So once you understand the pseudocode, once you understand the concept, you can actually code it in any of the languages that you are following this particular course in. So in order to understand hashing, let's take an initial problem. Imagine you're given this particular array, and now suddenly I come up and say, hey, can you tell me how many times does 1 appear in the array? And you can say that, hey, 1 appears twice in the array, right? Because 1 is appearing once here and 1 is appearing once here. So 1 appears twice in the array. And again come up and say, hey, can you please tell me how many times does 3 appear in the array? Now you'll be saying 3 appears once. Now imagine I again come up and say, hey, can you tell me how many times 4 appears in the array? You'll be saying it doesn't appear in the array. Now imagine I again come up and say, hey, can you tell me how many times does 2 appear in the array? You'll be like, 2 appears twice. Imagine I again come up and say, hey, how many times does 10 appear in the array? You'll be like, hey, listen, 10 doesn't appear in the array. So 10 is appearing 0 times. So given an array and you're asked a lot of times, very, very important points, very, very important point. You're asked a lot of times. First, you might be asked for any given number, then any other number, then again the same number. You could be asked for any given number of times for any number, and they might ask you how many times it appears, and you have to tell. Now, what is the first approach that comes to your mind when you think about it? Because you know for loops, right? The first approach that comes up is, hey, if someone says the number is 1, the first approach that comes up to my mind is, I will iterate through the entire array. What I'll do is I'll take this 1 and I'll compare it with the first guy, 1, and I say yes. And I'll take a counter variable, which is 0. I'll say this is equal to this. So I update it to 1. Next, I'll go to 2 and I'll say, is this equal to 1? I'll say no. Next, I'll go to 1 and I'll say this is equal to this. So the counter which was 1 previously will be updated to 2. Next, I'll go to this and I'll say, is this equal to this? No. Next, I'll go to this and I'll say, is this equal to this? And no. So the counter stays at 2. So if I have to write the brute force method in order to find how many times it appears, can I say it will be a function which takes a number. I'm writing a plain pseudocode. It will be a function which takes a number, and probably an integer function, because it has to return how many times it appears. And you can be like, for loop int I, or rather you also need the array in the function. So go ahead and take the array as well. Int function and probably array. Again, I'm writing the pseudocode, guys. I'm just writing the pseudocode. Please focus on the logic. So can I say, probably I'll take a counter equal to 0 and I'll say for I will loop from 0 and I'll loop till the last of the array. You already know this. How do you loop in the array, right? And you will say, hey, if array of I is equal to number, can I say counter equal to counter plus 1, and I can end this for loop and I'll say return counter, and this will be my code. Can I say this? Yes, I can say this. Why does this work? Because it's very simple. If you're given a number 1, that number 1 is given over here and the array is given over here, and you iterate through the entire array. What is 0th index? This is this. What is after this first index? This is this. And what are you doing? You're saying array of 0 equal to 1. Then you are increasing the counter. So eventually you will iterate through the entire array and the counter value will be updated at the end of the for loop. Once it is updated, you return the counter, correct? So in order to find how many times 1 appears in the array, what you can say is, hey, function, take 1 and take this particular array and tell me how many times it appears, and it will return you 2. In order to find out how many times 3 appears, you'll say, hey, function, take 3 and take this particular array and say how many times does 3 appear, and it does a linear iteration. It goes to every element and checks if it is equal and it counts it. And at the end of the day, it returns the count. Simple. So if I have to ask you, what is the time complexity? Can I say I'm running a loop for bgo of n times? And there are certain number of operations that we are doing, but we do not calculate that in time complexity. So can I say I'm running the loop for n times? Thereby the time that I'm taking in order to compute how many times a number appears is bgo of n. So for this, I will take bgo of n. For this, I will take another bgo of n. For this, I'll take another bgo of n. For this, I'll take another bgo of n. For this, I'll take another bgo of n. So can I say for 5 times, if I have to do 5 times, like these are 5 numbers. For 5 numbers, if I have to find how many times each of these numbers appear, can I say the time complexity is 5 into bgo of n? I can say. And imagine if I give you a lot of such numbers, like a lot of such numbers. If I give you a lot of such numbers, and imagine there are q numbers. I give you q numbers, and for every number, you have to tell me how many times it appears. Can I say the time complexity will be q into n? Can I say the time complexity will be q into n? Because for every time you are taking a for loop and computing it, so thereby the time complexity will be q because there are q numbers, and for every time you are computing n, so the time complexity boils down to q into n. And this is something which might not be good if imagine q is very large. Just imagine I'm giving you q to be 10 to the power 5. I'm giving you 10 to the power 5 numbers. And imagine I give you an array size. I give you a huge array of 10 to the power 5 size. And what will happen? Then it will be bgo of 10 to the power 5 because 10 to the power 5 numbers will be there. And the array size is 10 to the power 5 because it's a huge array. So the number of operations will be 10 to the power 10. And the number of operations is 10 to the power 10. How many time, how much time will it take? If you remember, I told you 10 to the power 8 roughly takes around 1 second. Most of the problems you'll find on DS algo will be taking 1 second or 2 seconds. So if I'm taking 10 to the power 10 operations, how much time will it take? It will take 10 to the power 10 seconds will take approximately 100 seconds. How do I get that? Very simple. If 10 to the power 8 takes 1 second, then one operation will take 1 second by 10 to the power 8. Then 10 to the power 10 operation will take 1 by 10 to the power 8 into 10 to the power 10, which is nothing but 10 to the power square, which is nothing but 100 seconds. So 10 to the power 10 will take 100 seconds, which is a lot of time. You cannot wait for 1.5 minutes for a program to execute.
Stop searching for high-paying job posts on LinkedIn and hitting the easy apply button, because that's not how companies.
This is where something like hashing comes in. It's a technique which will help you to do it in a much faster way. So if I have to define hashing in extremely naive terms, what is it? It is something like pre-storing and fetching. This is what hashing is. Pre-store something and fetch when required. This is what hashing is. Pre-store something and fetch when required. Let's understand this in depth. Now this is an array. Okay. Now imagine the problem statement states the array will at max have numbers till 12 or 15. Let's say 12. At max it will have 12. What does it mean? Over here you're saying 1, 2, 1, 3. So at max over here it is 3. But imagine a problem statement where I state I'll give you an array and the array at max will have 12. Over here it is having 3 at max, but the array can have at max of 12. So what hashing says is, okay, I know I can have numbers from 0, 1, 2, 3 till 12. So what I will do is, I will create another array. Okay. Remember this. I'll create another array and I'll call this as hash array. And in this hash array, what I'll do is I'll say 0, 1, 2. So what I'll do is I'll create an array of size 13. And I know the indexing starts from 0 and the indexing will go on till 12. And I'll assign everything as 0 initially. And this is something which I'll call as hash array. This is something which I'll call as hash array, or you can call it as a frequency array as well. Now what I will do is, I will do some pre-calculation. Remember this. I will do some pre-calculation. Now what is this pre-calculation? It's very simple. I go to the first number, which is 1. And I say, okay, you are 1. So I will go to the first index and I'll say, hey, can you just remember that I have 1, 1? So he will say, okay, I'll remember you have 1, 1. Next, I'll go to this 2. So it will come to this 2 and say, hey, can you remember I have 1, 2? He'll say, okay. Next, I'll go to this 1 and it will say, go to 1 and say that he has 1 more 1. So he goes to 1 and says, you have 1 more 1. So he says, okay, I know I have 2 1s. He'll go to 3 and say, can you go and remember you have 1, 3? He will do that. He goes to 2 again. He says, go and remember you have 1, 2. So 2 increases to 2. So apparently, the moment you have traversed for all the elements in the array, the hash array, if you properly observe, in one index, because 1 is the number representation, in 1 it states, I'm appearing twice. In 2 it states, I'm appearing twice. In 3 it states, I'm appearing once. And all the others are marked as 0 because they do not appear. So now, this is the pre-store that you have done. This is the pre-store. This is the pre-fetching that you have done. Now what will happen? Now you come over here and you say, hey, listen, how many times 1 appears? Now you do not loop and find out how many times 1 appears. What you say is, hey, how many times 1 appear? I have done a pre-fetching. I'll go to 1 and I'll say, it appears twice. I get twice. For this one, I go and say how many times it appears. And I'll get this value at hash of 1. Instead of iterating in the entire array, I say hash of 1 and it tells me 2. For this 3, I'll say hash of 3 and it will give me 1. For this 4, I'll say hash of 4 and it will tell me 0. For this 2, I'll do hash of 2, it will give me 2. For this 10, I'll do hash of 10, it will give me 0. For this 12, I'll do hash of 12, it will give me 0. So can I say I just did a single pre-computation and that apparently solved all of my queries in one go? So if I have to code this up, can I say I'll first be given the size of the array. Imagine this is 5 size array and 1, 3, 2, 1 and 3. So given this array, then probably I'll give you the number of numbers for whom I require, how many times they appear. I tell you I need for 5 numbers. And the number is first I'll say how many times 1 appears. Next I'll say how many times, let's say 4 appears. Next time how many times 2 appears. Next time how many times 3 appears. Next how many times 12 appears. So 5 numbers for which I have to find how many times they appear. So this is the size of the array. This is the array. How many numbers, like how many queries are you giving? And these are the queries. 1, 4, 2, 3, 12. Tell me how many times 1 appears. Tell me how many times 4 appears. Tell me how many times 2 appears. Tell me how many times 3 appears. Tell me how many times 12 appears. So I need to take all of these input. So it's a very simple way. First n and then scene of n. Then you declare the array of size n. And then you say for int I equal to 0, I lesser than n, I plus plus. Then you go across and say scene of array of I. Perfect. You've done this. What's the next step? You have to take the query. First I'm taking up all the inputs. Okay. Scene of q. So you can run a while loop like q minus minus. And then you can say take me the number and scene of number. So this is what is the input. First the array, then the queries, and for every query the number. Now you need to tell me how many times the number appears. So this is where you do some pre-compute, and this is the fetch method. This is where you fetch. So can I say for pre-computation, I need hash. I need a hash. And over here, for simplicity purpose, fetch number. And then you can say take me the number and scene of number. So this is what is the input. First the array, then the queries, and for every query the number. Now you need to tell me how many times the number appears. And then scene of n. Then you declare I. You've done this. What's the next step? You have to take the query. Let's first I'm taking up all the inputs. Okay, scene of q. So you can run a while loop like q minus minus, and then you can say take me the number and scene of number. So this is what is the input. First the array, then the queries, and for every query the number. Now you need to tell me how many times the number appears. So this is where you do some pre-compute, and this is the fetch method. This is where you fetch. So can I say for pre-computation, I need hash. I need a hash. And over here, for simplicity purpose, let's take 13 because I know at max the size can be till 12. Whatever the problem states, if the problem states the maximum size can be till 10 to the power 5, then you will go across and say 10 to the power 5. If the problem states 10 to the power 6, you go across and declare it. Over here, I've kept it simple. I've said that maximum size will be 12. So I require a size 13 because in order to have the 12th index, I need a size of 13 because the last array index is 12. All of us know that. Now, the pre-computation was very simple. I will go like this to the array. This is the iteration of the array. Now, I know for array element, I have to go to that index and do a +1. So I say, hey, go to that index, which is array of I, because that is the index where I have to go. And I have to tell him, can you increase your value by 1? And he increases because previously it was 0. Now he will, for every number it goes to that index and says plus equal to 1. Once this is done, now I have my hash array ready. So if I go back to the iPad, can I say I have this particular hash array ready after the pre-computation? Because 1 means hash of 1 plus equal to 1. So it goes to this and does a 1. And similarly for this number, similarly for this, and for this. This hash array is ready. The input is different, but it's okay. Once the hash array is ready, you have the number. You just fetch it. So you say C out of hash of number. This is the number of times it appears. And you can just go ahead and do this. I'll go ahead and quickly run this and see if it is running fine. So if you see, these are the answers. How many times 1 appears? Twice. How many times 4 appears? 0. How many times 2 appears? Once. How many times 3 appears? Twice. How many times 12 appears? 0. Depending on what is the maximum size of the array, you declare the hash. Now a question that might come up to your mind. Striver, in this you said the array could be having a max element till 12. So it is very obvious that you declare an array of size 13 because the last index then we will get as 12 and we can keep how many times 12 appears. But what if I tell you that the maximum array element can be till 10 to the power 9? Like it can have numbers till 10 to the power 9 or maybe 10 to the power 12 or maybe 10 to the power 15. What if they have larger numbers? Can we declare an array of size 10 to the power 9 plus 1? Because apparently that is what we are seeing. If there was an array of size at max till 12, we declared a size 13. So if the array has max element till 10 to the power 9, can we declare an array of size 10 to the power 9 plus 1? The answer to that is no, you cannot. The maximum size array that you can declare is 10 to the power 6 if it is of integer. Inside, very important, inside main, what does it mean? If I go back to the code, this is where you declare. If you're declaring it inside main, it can only go up to 10 to the power 6, like somewhere near about. You cannot declare something like 10 to the power 7. This will throw you segmentation fault. It will not be able to allocate that much memory. But, if you go across and declare it somewhere globally, which means over here, if I go across and declare somewhere globally, I can actually do it till 1e7, which is 10 to the power 7. So if you declare globally the array can go till 10 to the power 7 as well if it is declared globally. Like 10 to the power 7 plus 1 might also work. Near about 10 to the power 7, it will go. But if it is declared globally, very, very important. This is something which I'm talking for integers because we are dealing with hashing. For Boolean, yes, for Boolean, this value will be, if you're declaring a Boolean array, inside int main, you can go till 10 to the power 7. Globally, you can go till 10 to the power 8. You can run them and see if you declare anything like 10 to the power 8 inside, yes, inside your int main, it is going to throw you a segmentation fault. So let's go into the code editor and imagine instead of 13, I say 10 to the power 7. Okay. And now let's try to run this and see if it is taking 10 to the power 7. So if you look at the terminal, it actually says there is a problem because the memory size is something which it cannot allocate. But the moment I reduce 1 0 and I try to rerun, you will see that this is actually running fine. Let's run this. You see, it is running fine. And if I add one more 0 and I go across and declare this globally, you will actually see this is like you don't need to give 0 because if you declare globally, everything is initialized as 0 instead of garbage values. So if you go over there, I declared it. Hey, what is the problem it's giving? Oh, shit. Let's run this. Hash is ambiguous because okay, let's do double hash because the name is something which is already taken. Let's now run it. And you see it is working fine. If I declared it globally as 10 to the power 7, it did run fine. So this is something which I wanted to tell you. This is something which I wanted to tell you. If you are using array in order to do hashing, you can only go up to 10 to the power 6 inside a main or 10 to the power 7 globally, not beyond that. For something like 10 to the power 9, what will we be using? That is something which we'll be discussing in the later half of the video. So make sure you watch the video till the end. So till now, what have we learned? We kind of learned about number hashing. If there is a problem which requires number hashing, we can use arrays to hash them, right? What's the next thing that we will be learning? That is something as character hashing. Can we do character hashing using arrays? Yes, we can. And that is something which we will be learning. Imagine I give you a string like A, B, C, D, A, B, E, F, C. And I give you certain queries. And I ask you, how many times does A appear? Can I say once, twice is what A appears? How many times does C appear? If I ask you how many times C appears, it will be 1 and again twice. How many times Z appears? It will be 0. If you look at over here, that doesn't appear. And similarly, I can give you a lot of other things like Q queries. I can ask you Q times A, B, C. I can give you any character, and it is your task to tell me how many times does that character appear in this particular string. Again, what is the standard procedure? The standard procedure is very simple. You pick up A and you iterate in the string and you say A equal to A. Yes, count A equal to 1. A equal to A here, count A equal to 2. So you just basically iterate through the string, and in a similar way, you compare the character with each of the characters and you count it. So if I have to write the pseudocode, this is how the pseudocode will look like. You take the character C and you probably take the string C. And what you do is you keep a counter 0. And now you go through the string I equal to 0. Imagine the size of the string is n. You go till that and you say if S of I